I guess I don't see the recording icon, but I'll assume it's going. Yeah, so hello everyone. I'm Ben. I'm gonna be talking about TypeScript today. So as you can see, uh, Adam Victor, a former Cleverite and former intern, uh, actually made this presentation, and then I took it, applied a Google Slides theme, slapped my name on it, and made some minor edits, but this is mainly his work, and it's been really good in the past. He made it this live coding thing, which was awesome, I think. Because I use voice commands, I think that's a bit harder. So I'm going with like screenshots of the code, but feel free to put any questions in chat and I'll try to keep up with them. And maybe if you have a similar question, you can just like +1 other people's comments so I know maybe like to pause on that one and discuss it. So cool. We will just dive into talking about TypeScript. Okay. Wait. There we go. Okay, so yeah, so basically what is TypeScript? TypeScript is a superset of JavaScript with compile time types. So you can think of TypeScript as just JavaScript plus stuff. So like all JavaScript is valid TypeScript, but not all TypeScript is valid JavaScript is the way people say it sometimes. So yeah, basically with TypeScript, you're going to uh, write TypeScript code and then you run it through a TypeScript compiler. The compiler does two things. So it will check for type errors and report on those. And separately, it will transpile your TypeScript code to JavaScript. After that point, your types are erased. They're gone. So yeah, if you set up a minimal kind of repo, it can kind of demystify the process, but it's basically going to turn your TS or TSX files into JSX, and emit those, which then you run with Node or your web browser. Cool. So why TypeScript? The huge reason is type safety. It's a great feature. So it allows us to catch bugs at compile time before we ship them and they get to our users' browsers, where those errors can crop up at runtime. So that prevents flares. So every time you see a little squiggly red line in your editor and you fix that, that's a flare prevented. And yeah, it increases our velocity a lot through auto completion. You should know how to trigger auto completion in your editor and use it a lot. TypeScript's going to help you. It's easy to understand code as well. Types have this documenting kind of aspect to them, and it makes it more maintainable over time, and makes refactoring easier. So lots of reasons, and that's why just like most people use TypeScript on top of JavaScript these days. And then secondarily, a more minor point is you have early access to JavaScript features. So before optional chaining and knowledge coalescing existed in like ECMAScript, the JavaScript spec, those things came to TypeScript. So, all right, so moving right along. So yeah, TypeScript versus other type systems. So yeah, other type systems, you just think of that as like assigning some type, some like shape or description to a variable, right? That's what a type system is kind of in charge of, and alerting you when you're doing something incompatible. So TypeScript has a very flexible type system, because it's kind of designed specifically for JavaScript, and JavaScript is used in a lot of ways. So it attempts to match all of those ways. So we're going to talk about lots of different stuff. Type manipulation is towards the end. We might not get to it, but it can do that a lot, like basically building a new type from other types. We're going to talk about inference. So it can guess types for you. Structural types, we'll talk about this too. So structural types, TypeScript is a structural type system. And this is similar to duck typing. It's not exactly the same, but you can think of it as the same thing. Duck typing is the thing where people say if it walks like a duck, talks like a duck, it's a duck kind of thing. So we'll have an example of that. But yeah, this is in contrast to like Java, which has a nominal type system. So things are named there, whereas here it's like, does it act like a duck? That's all I care about, kind of thing. So talk about that. Type erasure we mentioned. So that's a good thing to keep in mind is like when you write TypeScript, like that type syntax will not make it to your end user's browser ever. That will get erased at compile time. So just something to keep in mind. And varying strictness levels. It's a very TypeScript level thing where you can be using TypeScript, but be getting very few of the benefits if you just turned off the strictness flags. Or you could be getting a lot of benefits if you turn strict true on, so full strictness. Cool. So moving right along. Okay, so because we're talking about a type system, on the following slides, errors are generally good. So when you see a squiggly error or like a straight line under something, that's going to be an error. And that's good because we catch it at compile time. So like when you're coding as opposed to when it gets to our users. So that's potentially a flare prevented every time. So that's what we want. Yeah, otherwise it's kind of silent and unknown to us. So, okay, we'll just dive in and we're going to start with the basics and build up from there. So yeah, this is just some basic types that you can specify. So starting with lines 2 through 4 here. So we've got strings, booleans, and numbers. We've got on 6 and 7, 2 different ways to specify arrays. So you can do square bracket syntax or angle bracket syntax. They're equivalent. So just, yeah, multiple ways to do something is definitely a, JavaScript and TypeScript hallmark, I'd say. Cool. So on line 9, you see us specifying the type for an object. And so this is in line. You could name this type and then, use that name here. But in this case, it's an inline type description. And notice we're not instantiating anything here. We're just saying, I'm going to have a variable C and it will hold information that looks like this, but we're not instantiating anything yet. So this whole type would be erased at compile time. So world here has a question mark after it. So that's an optional property on that object. Cool. And then functions, we use this arrow syntax typically. So you can describe the function signature. So accepts 2 positional parameters, and then it returns a string array. Or on line 12, just like returning void is just, no return value. Cool. And then escape hatches. Boo, but we do have any. So any, we're going to talk about in a second here, but it is a way to basically turn off the TypeScript compiler when it comes to dealing with this variable. So it's really convenient in the moment, right? But it could be very inconvenient if you introduce an error, and it's just like, it's certainly bad practice TypeScript wise to use any's, and it's kind of unavoidable, or at least really hard to work around in some cases, like especially in parts of our code bases. So I would just say if you see any's in PRs, maybe have a conversation about it. Think like, can we avoid this? Specify like any kind of type. Yeah, because it's gonna pay dividends down the road. Cool. And then unknown. So unknown is a better version of any. We're not going to talk about it too much, but you might look into that. It basically just requires you to specify what you want to treat this as when you actually use it. Cool. So moving along, the danger of any. So we're going to do 3 examples here to show how any might bite you. So, okay, you're writing code. You've instantiated this variable h as any, type any, but as the number 5. Now you go to use a function on it, like to lowercase, which is for strings. You're not going to get a type check error because you've said any. So the compiler is just ignoring h. So that's not good. If we typed it the correct thing, then on line 5, you can see that we're going to get this error. It does not exist on type number. So that's what we want. Very simple example. Another maybe more common one is if you assigned I to the string boo, and then you attempted to do lowercase on it, but you misspelled it, you're not going to get a type check error. And so that can be hard to notice. But very helpfully on line 10, you can see the error not only says this doesn't exist, but it suggests, oh, did you mean this other thing? So yeah. And then the third example is interesting. So in this case, we're just saying j as any is equal to null. And then on line 14, we say j dot to lowercase. There's no type check error. So that's as expected from before. But on line 15 and 16, you can see how we actually get this error. There's a really important caveat here, though. So what you need is a strictness flag called strict null checks on to get this error. So this is pretty wild if you think about it. So if you just think about line 15 and 16, with the strict null check on, this is great. You instantiate J2 as null, and then it says, hey, this is possibly null. You got to handle that case before you call anything on this. But with this flag off, which it is off in most of our repos, props to Launchpad for having it on, this will not be caught. So in school's dashboard, you can write line 15 and 16, and it's like no problem. It has no problem with it. I have a problem with it. Maybe you should too. So strict null checks is a big win. We're going to mention it more in the future, but yeah, it's an important way that we can catch these errors. So yeah. Okay, moving right along. Okay, we talked about inference a bit. And by the way, if I'm moving too fast or too slow, just say so in chat, like if you have any more questions. Okay, so type inference. So the type inference is really powerful and reliable. So what it'll do is it will infer types as you write code, and you'll get the benefits of full type safety despite no type annotations. So on line 2, we have this array of strings, and it will infer correctly that this is a string array. So if you hovered your mouse over the variable words, it would report that as a string array. And similarly with lengths, because this map function maps items to item.length, and length is a number, it knows that lengths will be an array of numbers. And similarly, like on that function, that inline arrow function, item.length, we don't have to specify, oh, item is a string. It's actually through the power of generics, which this map function uses. It like pipes through that words is a string array, and so this map function says for this callback, this is going to be a string too. So yeah, lots of inference going on here. No type annotations, but full type safety. And then yeah, on line 6, you can see we're trying to access a property that does not exist, and we're gonna get an error for that. That's great. And then finally, more of the same. If we just reference char at on line 8 here, then that's going to return a string, and so the final thing will be a string as well. So lots of inference going on as you write code. Yeah, just something to know about how TypeScript works. Okay, and now a little bit about the structural types. Okay, so I've got an example here. So there's a car that can drive, and there's a golfer that can drive. Not a golfer, but to drive as a golfer means to hit the ball far, as Adam tells us here. Which maybe this is from the TypeScript handbook, which there are links to throughout this guide, these slides. The TypeScript handbook is really good and quite readable, so I recommend it for any sections that don't make total sense here. So yeah, surprisingly, you can see on line 13 that we can make a driver variable. We can say this is a car, and then we instantiate a golfer. But yeah, this is structural types in a nutshell. It doesn't care that they have a different name. It just cares about what members that that each have. So they each have a function drive that doesn't return anything and doesn't have any function parameters. So great, no problem. Now, just building on that, if you just have any difference, like a property, a Boolean property, that's called has wheels on car, well, then that's going to have a problem. So yeah, in practice, this might not be a super common thing you encounter, but it's important to be aware that this is the way TypeScript works. And oops, yeah, and this is another really good one to understand. So in this third box here, so if we have a class empty and there's nothing in it, and then we have a function that accepts an argument of type empty, and then we pass something in on line 8, we can see that there's no error. So we're passing in an object that has a K property, which doesn't match empty, right? But an important thing about structural types is that it's basically like, does it include at least the members specified in the type? Then it matches, right? So it doesn't matter if you have extra things. And this is this gets to how TypeScript is in some ways a technically unsound type system, but it's mostly in relatively unimportant ways like this. It's maintaining some flexibility that JavaScript had to begin with. So yeah, this is important to understand, just that you can have additional things and still match another type. And it can be a nice thing to leverage. Okay, cool. So strictness, in your day-to-day, maybe you've written a bit of TypeScript, but you haven't thought about this too much. There's a tsconfig file, and in that configuration file will be some description of how strict the compiler should be checking. So fully strict TypeScript is really powerful, and I think it's just a thing that we should all be driving for. It makes your life so much easier. But if we can just get these two flags on, our lives become much easier. So this is a bit of an easier goal to achieve. So yeah, you can basically say strict is true in that file, and all of the strictness checks are on, but you can also specify them individually. So here's no implicit any, for instance. So if TypeScript can't infer a type, it will implicitly call it any. So without this on, it's going to be okay doing that. But yeah, if you turn it on, it's going to give you an error, and it's going to say, couldn't infer this type, please specify something more specific. And yeah, Adam did a lightning talk on how they approached turning it on in Launchpad. And I think at this point it'd be pretty easy to extend to other repos. So could be a fun little project. And then strict null checks is the big one. So if you see those like question marks everywhere in like school's dashboard, yeah, there's lots of any types in school's dashboard and lots of question marks. Like we're definitely, feeling the hurt. It's like we have types, but yeah, we don't have the confidence in them, right? Like you still see errors that are confusing. It's like, I thought this was of that type. So if we change our approach a little bit and start rolling out strict null checks, we can get to a really nice place. So yeah, so strict null checks should be a goal for everyone, and that was rolled out in Launchpad as well. And uh, yes, Sam wants it too. So yeah, I think we should, spoiler alert, I really want to do this for School's dashboard, and then it'll be a definitely a group project to actually like apply strict null check like safe code everywhere. So cool. So strictness, good. Okay. So what are we doing now? Okay. Yeah, just a little bit about the strict null checks again. I can go through this quickly because we talked about it a little bit, but in this case, we have a user, there's a name, two optional like email and phone number, and then a nickname, which is kind of optional in that you can provide, so the nickname can be of type string or null. The pipe is a union operator, so we'll talk about that in a second, but you can think of optional properties as being string or undefined. Remember that undefined and null are separate values in JavaScript. So yeah, so you can think of email question mark as being really like string pipe undefined. But yeah, you can see that with strict null checks enabled, we will get type check errors here, which is great. And on the flip side, like if we don't have it on, when we do these console logs, we're not going to get type check errors, but those will be runtime errors if we use this instantiated user, which doesn't have a nickname, for instance, and doesn't have a phone number. So yeah, really important one. And then just a little bit about type narrowing. So this is another TypeScript feature where in a world where we have more strict null checks, okay, me.email can be either string or undefined. So how do I get around, like, I really want a console log that? So you can utilize type narrowing. So on line 2 in this top right box here, we see that we're saying if me.email. So the only way we'll get inside of this block is if it's a truthy value. So for that to be the case, it has to be a string and it can't be undefined. So the TypeScript compiler will understand that. And inside of this block, it will know that me.email is a string. And similarly, you'll know phone number is a string and nickname is being checked more explicitly here with this type of. And so this is called type narrowing. And it can be useful. It's the correct pattern when you have these like unioned types and you want to say, but I want to handle a case where it is this thing. So yeah. Okay. Cool. Moving along. I'm just gonna do a quick time check. Okay, we're at 28 minutes. So yeah, I'm gonna keep going. I don't think we'll get to everything, but yeah, whoever is in charge, just play the walk-off music and I'll know to wrap it up, I guess. Okay, so interfaces versus types. Yeah, you'll see both of these around. They are really just aliases. They're just a way to combine other types together into a new name. Things are still structurally typed. So interfaces are specifically for object types and type is more broad. So they're both pretty similar. It's often the case that you can use either one, so don't sweat it too much. On this last line here, you can see Adam's rule of thumb is if it's a simple object type, use an interface, otherwise use type. So both can be extended. So just as an example, we have an animal interface and it has a name, and then we have a bear, and that's going to extend animal with another property called honey. You can do the same exact thing with types, and that would look like that below. So you would say type animal 2. That's pretty similar, but it includes the type keyword and an equal sign. And then on line 13, you can see we're using the ampersand, the intersection operator, to basically like, extend animal two with more properties there. So I think of types as allowing more like mathy kind of operations. So yeah, another feature that exists. Uh, so you've got interface declaration merging. So this isn't super common, but it's good to know that it exists. It's common in libraries like Express, where you might have some definition for express request, but elsewhere it's relevant to like add more parts to that definition. So this allows you to write the same interface name across different files, and they will be combined. So that's not a thing with types, only interfaces, and it's called declaration merging. So in case you're like, going to type definition, you find something really small and it's an interface, yeah, you might keep in mind that there are other definitions potentially. Cool. Yeah, I don't know if I have a fully formulated opinion on this. I think maybe it's useful for writing libraries, but I'd have to think more about it. Okay. So we'll talk about unions because this is an important concept. It's basically a way of combining possible types. We've seen them a little bit before, and we've seen a little bit about narrowing, and discriminated unions are great. I think I might skip um, discriminated unions for now, but it's a really powerful concept. And this link that Adam really likes, it's a very short article and entertaining, and I do recommend it, Making Invalid States Unrepresentable. So you might just read that to understand the use case and the like value add of discriminated unions. But yeah, real quick. So unions, you'll see these around. Basically, these are some simple cases. You're saying G1 can be a number, string, or null. G2 can be number or undefined. So if you're to, or you might think in your head before I show you the answer, if you're to like union these or intersection them, what do you think you would get? So you will get basically you'll kind of collapse G1 and G2 for the union example. So the fact that number is in both isn't really relevant. Just it's anything that either one could be. The intersection example is right the intersection of those two types. So it can only be number in that case. Yeah, so these slides exist if you want to look and think about that a bit more, but here's some more practical examples. So you can inline these unions as types, and in this case we have an ID, which is a number or a string. And you can see that on line 7, when we use an object in place of that argument, we get this error, right? One thing that Adam noted, I've been taking out the most important parts of these errors, but he had this great pro tip, which is like, if you're looking at a TypeScript error in your editor, you'll see this like big block of error sometimes. Look at the bottom. The last line is usually the most specific and most relevant bit. So in this case, it's actually more specific, I think. Well, not in this case necessarily. Sometimes it's a big block, and just remember to look at the bottom. Okay, ampersand in types is confusing. On one side, it's used as union of types, and here it is an intersection. Yeah, I think I know what you mean. Like, it's kind of funny. And I probably need to like revise my mental model on why this is the case, but you can think of on line 5 here, this ampersand, purely like as an intersection. It makes more sense as an intersection in my mind here. It's like, okay, we have G1, these 3 things, G2, these 2 things. Think of a Venn diagram, like what's in the middle, what's the intersection. So that's one use of intersection. Whereas in this other case on the left here, so the ampersand, it's more of an extension. So it's one of those things that like I want to revise my mental model. Maybe we can continue this discussion in the front end channel or something. But in the case of like interfaces and objects, you can think of this more as like extending, kind of an extension operator. But yeah, I feel like mathematically it must make sense somehow. So maybe, yeah, unintuitive, because I feel the same way, assuming I am understanding your comment correctly, Divya. Okay, so yeah, moving along. Okay, so wait, this is where we were? Yeah. Okay. So yeah, this is more about type narrowing. So yeah, this is a bit of a repeat, but what I want to say here is basically in this final example, we're using type narrowing again to kind of discriminate a type, narrow a type in each of these branches, right? You can use this type of operator, but it's really important to know that type of, this is runtime code, right? Like this line, if type of ID is string, like that is going to be running in a browser in Node when TypeScript doesn't exist anymore. So what's going on here? Well, JavaScript has a type of operator and it has a concept of types, but they're very general. Basically, you can use type of on any variable and it will return a string with, some value like a string or a string number or a string object. But if you name a type like, like our union example or intersection example, this type of ID won't return a TypeScript type. It will be returning a JavaScript type. So you might keep that in mind. Type of ID wouldn't work with a more sophisticated type. It's just like these primitive types. So yeah. Cool. So this is type narrowing in action again. Cool. And then this is discrimination, and I think it's a little bit yeah, I kind of want to just move past it, but if there's time, I think we could circle back. It's a pretty cool pattern, and I think it has limited use cases, but is a great easy way to do things. Cool. All right, so we'll touch on enums briefly. So yeah, so enums, I guess this can be a little bit of a controversial subject. Enums are such a classic part of type systems and other languages, but you might just be aware that there's trade-offs here. Yeah, it's getting spicy. So string unions are an alternative to enums. Enum is kind of funny because it's a TypeScript construct that adds runtime code. And yeah, the string union approach, spoiler alert, is my preference. I think you'll find it in the vast majority of cases in like library code, not to, put my thumb on the scales or anything, but okay, I meant to do this one like box by box, but so basically you can look, we'll discuss some of the trade-offs here, because I think this is one that we run into pretty often. So you can create an enum just like usual. Student, teacher, district admin, these will be given numeric values. So it'll be 0, 1, 2. So on line 6, you can see that we have a function that accepts user ID and user type. And now we go to use that function. So on line 8, sure, we can use user type enum.student. We will have to import user type enum if we're in a different file. So slight drawback sometimes. Surprisingly, on line 9, there's no error if you put a number there, because again, it's a numeric enum. At least on line 10, you are getting this error that, 5 is not assignable. So maybe you say, okay, let's do strings. It's getting more verbose, right? But this works a little better in that, you can't put a numeric value. So on line 8 and 9, you can see ways that it can work. You'd have to import this enum again, but you can use the enum.student. And then on line 9, you can say, okay, I want to just do student. That should work, right? But no, the type was this enum type, and that's not student. So it's a little confusing why that doesn't work to me, but it doesn't. So and a great, like, I think pretty idiomatic way to do this in TypeScript, which it might be confusing. It's like, I learned that enums are the way to do this. Why do we have this other way? But I think it's pretty clean and great. So, okay, and you in this final block, you can see that now we just have a union, and it's, these 3 strings, and basically we say the user type parameter of this function is now this union type, and this is something that we don't need to import anymore. So on line 4, you can see that I am just typing out student. So that works. That's great. No imports necessary. You do get auto completion. So this is another time where you should definitely experiment with this a lot. Like you should, like, you can do the opening quote and then do autocomplete, and it should give you, the 3 options: student, teacher, district admin. And if you misspell it, it will alert you to that. So this can be a pretty clean way to use this union type across different files, different consumers of that function. Don't have to import anything. They get the benefits of like type checking and auto completion. So yeah, maybe a little like unintuitive, but I think a pretty good pattern. But they both work, and this isn't like, it's kind of more a subjective thing. So okay, cool. So I have like less about generics. It's a pretty deep subject, and I think they're fun, occasionally pretty annoying, but they are very powerful. They do exist in TypeScript. I think the need, like, I didn't include much about it because like in a practical sense, it's not often that we need these, but you should know that they exist. It's a way of relating different types. So if you're writing a map function for some reason, you want to be able to say this works for an arbitrary type. So you want to accept a type as an input and then return a type or use that type somehow. So it's about relating multiple types. And there's this golden rule of generics. A little too deep for this, but I definitely recommend checking it out. It kind of gives you this very simple rule about when a generic is necessary, and how you can very quickly tell. So yeah, recommend that one for sure. Cool. And then, yeah, this is just not diving deep at all, but this is just what the syntax looks like. So you can see we've got this get random element function, and that's all it's accomplishing is just finding a random index, but it's typed as any, which is not great, right? So the better way to do this would be with generics. So you see this angle bracket on line 9, which says this function accepts a type, and then that type I will now use. It will be the array that is supplied will be of that type, and then the return value will also be of that type. So you can see on line 13 that it's actually inferred. So you don't actually have to supply it, although it'd be right here after get random element generic. You can include angle brackets and specify string here, and it would still work fine. And sometimes you might need to do that, but generics are great because, like the other parts of TypeScript, it benefits from inference. So you might be using these generics under the hood a lot, but not have to like verbosely write them out, kind of thing. So, okay, those exist. Yes, that's right. So yeah, that's very true. This is a really common use case for generics in our case. So when you do use state in React, which is a hook, you are often like giving one value to that, and it will be like, true or false, or a number, or, whatever type of thing you want to initialize that state to. So it's doing some inference there, and it's finding okay, this is of that type. So I know that, this use state is for a Boolean, and then it can use that type to return your use state return values, which are like the set function and then the value. So yeah, that's a good example of it in practice. And sometimes it won't be able to infer it correctly. And so then you need to use those diamond brackets after those angle brackets after use state to say it's actually this. It's actually this like model from IDM config service. So yeah, that's a great thing. Anywhere it can be useful just to specify it just for like just at a glance knowing what's going on, even if it was inferred correctly. So yeah, okay. So yeah, I'm getting towards the end of this talk, which yeah, we're at 45 minutes, so that maybe that's good. And yeah, there's lots of type manipulations that are possible. I'm not gonna dip into these, but I'll show you some related stuff on the next slide. There's lots of powerful things you can do with types. I'll just mention one thing here is like we saw a little bit with unions, and I meant to mention this. On line 1 in this last block, we're saying student or teacher or district admin. So in this case, this is a type statement. So this is Typescript that will go away at compile time, but we are using string literals here. So one of the powerful things that Typescript does is lets type literals be types. So the string student is a type, and the only types that match it are going to be the literal string student. The only like value that would satisfy that type is the same string. So that's like kind of interesting on its own in this use case, but it gets really powerful when you do things like template literal types, because when you write a string template like in JavaScript, that can be great for like building a string based on the input of some other thing. And you can do the same thing with types. So it's pretty wild. I'll leave that one for everyone to look at, as well as conditional and map types. But yeah, utility types, this is, I'll just give this as a final note. There's some cool things you can do. So if we've got this to do on the left, it's got some properties, whatever. And then you've got these utility types. These can be really helpful. If you want to say partial, required, read only, there are ways that you can basically manipulate a pre-existing type in this simple way. So a partial to do would basically be an interface that is, how does partial work again? I think partial is that everything is optional. So yeah, so basically partial would apply to do, apply like optional, the question mark to every property of to do. So maybe you'll have some use case where this is useful. It's like, I don't want to rewrite it, but these are all optional. Partial is your friend. Similarly, required will just make any optional ones required. Yeah, read only can be great. It's like, I do not want to change this, but other consumers might accidentally go about changing this value. Well, you can say, okay, it's a read only to do. So anything that uses something of this type should not be doing any assignment. So that can be great. Cool. So there's more there. There's omit and pick for like saying, I want this type, but I want to omit certain properties, or I want to pick only this set of properties. So there's even more than this. And yeah, another good one I wanted to mention is record. So instead of this top line on line 2 of the third block here, you might be tempted to define a map this way, with a key that's a string and then to do as the value. You'll run into, yeah, no, okay, I didn't include the example where this causes some problems, but you should just be aware that record is a utility type for doing exactly the thing above. and it's just a little more idiomatic and covers some edge cases with like type errors that are just silly and annoying. So I won't get into that, but just know that record exists where it's a generic type. So you're supplying string is the key type, and then to do is the value type. So that exists. Um, yeah, okay. Partial used in unit testing. That makes a lot of sense. Yeah, I think utility types in general in tests are great because, you're less concerned about strict typing there and more about like setting up some scenario to test. So, yeah, that's a great point by Divya. Cool. And then, oh, okay. So I did include pick omit here. So, yeah, this is an example of saying, I want the to-do type, but I only want specific properties in that interface. So you're saying, I want this new to-do preview, which only has a title and completed and you could accomplish a similar thing with omit, where you're specifying properties to exclude. Cool. So I think that is it. So that's all I had. Sorry if it was too fast in some places, but hopefully the exposure is helpful. And there are these handbook links throughout. And I'll have like a repo that's kind of messy, but it has all of these code samples that I can link to if anyone wants to see it. And that's it. Any questions? Okay. Well, thanks for listening. Um, yeah, Sam, I included a link to these in the front end channel. Yeah, and I'll include a link to the code. I'll just push it to a repo. But yeah,